Hello everyone, thank you for joining our talk. Today I'm gonna talk about parallel rendering, a cloud gaming solution in the Yahaha Universe. First of all, cloud gaming is a technology that allowing users to play games on remote servers via the internet, without the need to download or install the game on their local devices. Typically, cloud gaming services provide users with access to a library of games which can be played instantly on a wide range of devices through interactive video streams. But why do we need cloud gaming? Well, it has to begin with the Yahaha Universe. We have a studio for making fantastic games and beautiful scenes. Community developers can exhaust their imaginations and unleash their creativity by using millions of game assets in a no-code way. Those talented developers have contributed plenty of attractive games to our platform. But how can we deliver those high-quality products to users in an efficient way? Well, currently you can access all the games by downloading our application on all kinds of devices, but we want it to be more convenient and more accessible. So we want to deliver those fantastic games through web browsers. Now, yes, we need it, but how can we achieve this? There are two classic approaches. One is using Android devices as a cloud, or utilizing Qualcomm chips to build ARM clouds so that we can run Android applications on servers and send graphics to users in video streams. In this way, applications are executed in the same way as they are on users' mobile phones. The other is to virtualize a remote PC with high-end hardware for users to play. In this manner, applications are running on the PC as usual. Mostly it utilizes x86 architecture machines. However, both of the two methods have their own problems. When using an Android device, rendering performance may be limited by the hardware performance of the Android device itself, which may have limitations for high definition and complex scenes. Using x86 can solve this problem, but the cost of a single x86 server is much higher than that of an Android device, making it difficult to control the cost of cloud services. Therefore, we propose a new solution called parallel rendering, where a single machine with powerful GPU can serve multiple users at the same time. There are three parts: load balancer, rendering server group, and game server. The load balancer is in charge of discovering, monitoring, and distributing user requests. The rendering server, as its name suggests, is responsible for rendering the game scene, in addition to distributing the video stream to users corresponding to the rendering result. Each rendering server in the group can serve multiple users, while rendering servers are deployed all over the country to ensure that everyone can gain access and have lower latency. All of them will connect to the same game server so that players can interact with each other in the same virtual world. Besides, through this architecture, it's easy to scale up and down. Game servers will handle all game logic calculations and synchronize the state to the corresponding render servers. When users come in, the load balancer would help to find the right game server to join according to the requested games. Then the closest rendering server will be allocated among all the available instances. Users will connect to the allocated rendering server using WebRTC and send commands to game servers. In our solution, we offer two modes: the fixed camera mode and follow camera mode. The fixed camera mode works like surveillance cameras. We can set up multiple cameras with fixed transform so that the load of rendering is reduced and each rendering instance can serve as many users as it can. The bottleneck only resides in the reliable and efficient distribution of rendering result, which can be optimized a lot. We adopted it at our annual company party, as the GIF demonstrated. It's worth mentioning that we can add screens to the game, and it's pretty interesting to see the fusion of virtual and reality from a surveillance-like camera. We tested the upper limit that a single rendering server can host using our annual party games on a machine with RTX 3080 Ti. With output of 1080p graphics for each camera, a cloud server with 16 vCPU and 32GB memory can serve up to 100 users simultaneously, and the load of CPU is 55%. The GPU load is 45% 3D and 32% video encode. The biggest advantage of fixed camera mode is that a rendering machine can serve many more users at the same time, so that the cost is acceptable and the visual effect is perfect. However, it doesn't fit all scenarios. Users sometimes feel confused because they cannot rotate the camera, and it may be hard to find where they are. As a result, we also provide a follow camera mode, by which every player is assigned a follow camera as what it looks like in a Euro app. This makes sure that the good user experience is fully retained, and we can still serve multiple users at the same time. Besides, we can offer a combination solution of these two modes, allowing the same game to switch between fixed camera mode and follow camera mode, providing a more flexible way of presenting for cloud gaming and helping users explore the cloud space from multiple perspectives. We also tested the performance of follow camera mode. Using NVIDIA A10G with output of 1080p, 20 users can be served using an 8 vCPU machine. The CPU load is 40% and the GPU is fully used. Machines with 16 vCPU and with RTX 3080 Ti can serve up to 40 users per instance when the GPU is full of load. To summarize, our solution can reach a better balance in cost, scalability, latency, and security. For cost, we can be more cost-effective than building a dedicated server infrastructure for each player, or relying on a cloud-based solution. By utilizing machines with powerful GPU and deploying multiple rendering servers, we can provide high-quality gaming experiences to multiple users at a lower cost. For scalability, as mentioned earlier, this solution is highly scalable, as we can add or remove rendering servers as needed to handle fluctuations in user demand. This can help avoid over-provisioning resources and ensure that we are using hardware efficiently. For latency, by deploying rendering servers across the country, we can provide low latency access to a large number of users. This can be particularly important for online multiplayer games, where even a small delay can impact the overall gaming experience. For security, since all game logic calculations and state synchronization are centralized on the game servers and rendering servers, we can ensure that user data is kept secure and that cheating or other forms of gaming fraud are minimized. To sum up, we have ARM solution, x86 solution, and our proposed solution. For ARM solution, due to the limited performance of Android hardware, the visual effect and the performance are restricted to some extent, but it costs less, has good compatibility, and can retain full functionality. For the x86 solution, it requires better hardware, and each instance only serves a single user, which leads to higher costs. But it can provide a perfect user experience and also has good compatibility and full function. Well, by compatibility, we mean the app and the game can be executed directly on top of it. For our solution, rendering servers with better hardware can serve multiple users at the same time, which is cost-effective and can provide good experience simultaneously. But it requires adaptations for games to run, and currently not all the functions in the Yahaha app can be used. Since all these solutions have their own pros and cons, we can use them in combination, depending on the use case. For instance, to host minigames, the ARM solution is enough to both render and process, and it's easy to adopt. For AAA games where high frame rates and low latency are critical, both parallel rendering and x86 solutions are adequate. To make cost controllable, we deployed the parallel rendering solution for the demo on our official website so that higher concurrent visits are allowed and better visual effects are provided. By combination use, it will be much easier to have fun in the Yahaha Universe. To elaborate further, we offer a comprehensive Metaverse solution that is specifically designed for business use. Our solution provides a convenient and user-friendly platform for individuals and organizations to create a wide range of experiences using our no-code Yahaha Studio. Once the game or scene is created, it can be published in a cloud gaming way, enabling anyone with an internet connection to access and enjoy it from anywhere in the world. This means that businesses can reach a much broader audience and provide engaging experiences that are not limited by physical location and physical devices. We can use it for games, galleries, concerts, product releases, online weddings, and more. This means that businesses can reach a much broader audience and provide engaging experiences that are not limited by physical location and physical devices. Our Metaverse solution is a cost-effective and efficient way for businesses to create immersive and engaging experiences that drive user engagement and boost brand awareness. With our platform, businesses can easily create unique and compelling experiences that capture the attention of their target audience and help them achieve their business goals. Well, that's all that I'm going to talk about today, and thanks again for attending this talk. If you have any questions or suggestions, or are just curious about our solution, please feel free to visit our booth S441 and talk to our crew. See you there!